All right, let's just try to finish up what we did yesterday. So it's section 2.2b. Oh, I forgot to put a space on there. All right, that's going to irritate me. There we go. I feel so much better now. All right. So yesterday we talked about slope. Let's just write that down. Do you remember what the slope was? The change in y over the change in x. You'll hear it referred to that quite a bit, so I want you to just be familiar with that term. But what does that mean, the change in something? What do we do with those when we talk about the change in something? From point A to point B, I said, how far did you go? What do you do? What is it? What do you do? From point A to point B, answer the specific question. From point A to point B, you want to find the change or the distance or the length. What do you do with those two numbers? You just subtract them, right? That's all I was getting at, all right? So you just subtract them. So the change in y, you just subtract them. It doesn't matter what order you subtract them, but most books do it like this. Okay, or you could write it y1 minus y2. And that's fine, as long as you do what? x1 minus x2, right. Okay? All right, either way is perfectly fine. So, for instance, here's an example. I don't think we did the example yesterday, did we? Did we? Okay, thank you. So here's what they say to do. It says just find the slope between these 2 points. So we're going to find the slope. All right. Technically, the whole problem is find the slope of the line passing through these 2 points. I'm not going to write all that down. I'll just put the 2 points. So negative 8, 5. That's 1 point. And here's our second point for negative 3. Okay? And I got to find the slope. So I need a little formula. Well, I just happen to have a formula. It's right here. So let's put it in. You can use either one. You can go the second y minus the first one or the first one minus the second one. It does not make any difference. I'll tell you what I probably normally do. I probably just take that first one minus the second one. That's, when I look at it, that's what I usually do. It works either way. It doesn't make any difference. All right, so let's just do that. Let's go 5 minus what? That's my y. Remember, this is my x1 and my y1. This is my x2 and my y2. So I subtract the y's from each other. Again, it doesn't matter what order, as long as you subtract the x's in the same order. So what is it? Is it 5 minus 3? Minus, minus, very good. It's minus a negative 3, all right? So you're subtracting a negative 3. It's a common mistake people make. When you get negatives on here, especially when the second one's negative, a lot of students just look at this and say, oh, that's 5 minus 3. It's not. That's not a 3. What is it? It's a negative 3, that's right. So 5 minus negative 3. So let's do the same thing with the x's. I got to go in the same order. So if I went the first y minus the second y, I absolutely have to go the first x minus the second x. All right? So that's going to be negative 8 minus 4. And then you just simplify that. You'll get a fraction, reduce the fraction if it can be reduced. If not, just leave it the way it is. Minus negative is plus, so that's an 8. This is add the opposite. That's a negative 12. Do I leave it like that? No, because 4 goes into them both, right? 2 and 3 times. You can put the negative on the bottom. You can keep it on the bottom if you want. If it was me, I'd probably put it right in the middle. I kind of like it like that. Or you can put it on top. Doesn't make any difference, does it? All right, as long as you just have that one negative. It could be on the top, the bottom, or right in the middle. I kind of like it right in the middle. There you go. Everybody good? Okay. Let's just talk about this real quick, and then we'll do really what this lesson's all about. Let's use this. All right, so what if I had... tell you what, I got one already over here. Let's just grab this thing. All right, we're going to put a few of them on here. Come on. There it goes. Let's put another one.
Mr. Hammer?
Yes.
Can you send Lily to the office for a moment?
Okay.
Thanks so much.
All right, here we go. We'll do a couple more of these in a second. What if you had a line like this? See that red one? Without putting any numbers in it at all, you should be able to tell what the sign of this slope is. All right. So from left to right, what's it doing? If you start here and you travel along that red line from the left-hand side, you're traveling what? Up the slope. Okay. So what kind of sign do you think is associated with a slope that goes up like this? It's positive. Exactly right. Okay. This is positive. So that's a positive slope. We should just be able to look at it and tell. All right. Now sometimes, like if your slope was like 0.1 degrees, it'd be hard to tell if it was horizontal or if it was positive, right? So, but for the most part, you can just look at it and say that that's a positive slope. Let's just take a look at it real quick on why it's a positive slope. Just because I said it goes up going from left to right? Not really. I'll pick any 2 points. I don't care. All right. Again, I don't know the numbers associated with these. I'm just looking at the signs. So watch. Rise over run, correct? That slope, changing y, we're changing x. Let's think rise over run. So in order to get from one point to the other, let's start with the left one. Right? If I wanted to go from this point to this point, but I could only rise and I can only run, what would I do first? I'd rise to here, and then I'd run to there. So rising, I went up. What direction is that? That's positive. Then I ran to the right. What direction is that? That's positive. What is a positive over a positive? It's a positive, and that's why it's a positive slope, okay? But if you just look at it, you should be able to tell from left to right it goes up. There you go. That's correct. Okay, you always, right? We read from left to right. So you're just looking at this as you're going left to right. You're going up the hill, right? If you were here and you're moving in from left to right, you'd be going up the hill. That's positive. That's how I like to look at it. Okay, we okay with that? What do you think the next one's going to be? Take a wild guess. Come on, talk to me. Yeah, it's going to be negative, all right? And so there we go. So what kind of slope is this? Just by looking at it. It's negative. How do we know it's negative? Because from left to right, what are you doing? You're going down the slope. Okay, so that would be negative. Going down is negative. Let's do what we did a minute ago. Let's put 2 points. Pick any 2 points. I don't care. So we got to get from this top point to this bottom point. So we can only rise. We can only run. So what am I going to do? I'm going to rise that direction, and I'm going to run in that direction. Everybody see that? So my first rise was what? I went down, so what sign is that? It's negative. I went to the right, what direction is that? Positive. So it's rise over run. So it's negative over a positive. What's any negative number divided by any positive number? It's a negative number. So this is a negative slope. Let's make it. Yeah, good question. I was about to do that, but I'm glad you asked. What if you wanted to go from this top one to this bottom one? All right, let's go back to the positive slope. What would you have to do? You'd have to go down, right, which is what? Negative. And then you'd have to go what? To the left, which is negative. What's a negative over a negative? It's a positive, so it's still a positive slope. Doesn't matter if you go from the top point to the bottom one or from the bottom one to the top one, it's still going to come out the same for both of them. We good with that? Okay. Same thing here. Watch. What if I wanted to go from the bottom one to the top one? What would I do first? Well, I went up. That's positive. But then what did I do? I went to the left, which is negative. Rise over run, positive over negative is still what? Negative. We good with that? All right. Let's do a couple more that are kind of a little different. So we got positives, we got negatives, but we have two other versions of slopes. Okay, and let's do this one first. All right, let's take a look at that one. Is that positive slope? Doesn't look like it. What does that red one look like it's doing to that x-axis? Or what do they look like they have in common? They're what? Well, they're parallel. Looks like they're parallel. That's what I was looking for, okay? It looks like they're parallel to each other. All right, so it must mean it's horizontal, correct? So if you have a horizontal, that is correct. Okay, the slope is actually equal to 0. Now I could just sit there and tell you that and move on to the next one, but I just want to show you why, kind of like what we did before. All right, let's pick 2 points. 1 point here, 1 point here. Huh? Horizontal. That's horizontal. All right, so we got to get from this point to this point. And how do we get there? We have to rise and we have to run, correct? So how far do we rise? That's right. We don't go anywhere up and down, do we? All right. So my rise is what? 0 over the run, which is that far. Now I didn't put any numbers in there. I'm not really sure, but we'll call it x, right? Since we're going in the x direction, we'll just use that for a point. What's 0 divided by x or any other number? It's always 0. So that is why the slope of this is 0. Yeah, 0 divided by anything is 0. Okay? 0 divided by 1 is 0. 0 divided by a negative is 0. 0 divided by a fraction is 0. 0 divided by a decimal is 0. Okay? Yes? Say that again? This? No, this would not be no solution. This would be 0. Okay, it's got a 0 slope. I want to try something. Now, if I'm going to chat GPT something. Yeah, use it all the time. I'm pretty sure about my answer. I just want to see. Yeah, okay, I was right. So, remember I said 0 divided by anything is 0? But what about 0 divided by a 0? You could look at it 2 ways. You would, well, that's 3 ways, okay? Anything divided by itself, we say is 1, correct? So you would think that 0 divided by 0 is 1. It's not. But you could also look at it as, well, 0 divided by anything is 0. So 0 divided by 0 must be 0. It's not, okay? I'll show you something else. We'll get back to that. We'll get back to it. I'm not going to leave you hanging, don't worry. Watch this. Okay, what if you had a line like this? What kind of line? This was horizontal. Horizontal, right? Means it goes across like this. This is vertical, all right? So know those words. In photography, when I hold my camera like this, I would say that would be horizontal. And then I hold it like this, that would be vertical. But nowadays, people don't use those words. Back when I was doing photography in the olden days, that's what we would always say, horizontal, vertical. Now what do they say? If your picture looks like this, landscape, right? And what do they say for this? Portrait, right? Okay. So I got to get used to that myself. But yeah, some people say horizontal and vertical. But if I was going to shoot a picture like that, I would call it horizontal. Shoot one like that, that would be vertical. But nowadays, people say landscape and portrait because it says that on your little iPhone thing, doesn't it? Right? On how you want to crop it and stuff like that. But anyway, so vertical. So know those words. This is up and down, straight up and down, okay, if you want to say it like that. But that's a vertical line. Now, let's go through that whole thing. I'm not even going to tell you what the slope of that is just yet. Let's put a couple points on here like we did before. Put a point here and a point here. Now, how far, let's go from this top point to this bottom point. How far do I rise? Well, I don't know what the number is, do I? So we'll call it y. Yeah, we'll call it y. You can call it negative y if you wanted to, all right, if you're going down, or you can call it positive y if you're going it up. It doesn't make any difference because of the next thing that we're going to do. So I rose, or I rise. It wouldn't be rised, would it? I guess I rose. Y number, whatever the number is, okay? How far do I run now to get to that point? 0. I'm already there, right? So I don't have to run. I don't have to go left and right. So I'm going to go 0. Now, look at this. Look at the difference between this and this. Look, I'll put it in a calculator. Have you seen my calculator? Have I shown that to you? Have I shown that to you yet? Haven't? Okay. Yeah, exactly right. So watch. Y, any number at all. It doesn't make any number. Call it 5. All right? Let's say we went down 5. All right? You can call it negative if you wanted to. Whoops, I didn't want that. Hold on. Negative 5. Let's say we went down negative 5. Divided by what? 0. All right? Let's see what we get. Boom. Oh, didn't like that at all, did it? All right? It says it's an error. Error. And it even tells you on this calculator what the error is. Okay? It's because you're dividing by 0. You cannot divide by 0. All right? It would be undefined. Exactly right. Okay? So the slope of this line right here, we say, a lot of times we'll say this. We'll say that there is no slope. Now, a lot of students say, well, what's the difference between 0 slope and no slope? I thought 0 was nothing. Right? Well, 0 is not nothing. That seems weird. But we can add 0, right? We can multiply by 0. We can take 0 and divide it by something, right? So 0 is something. It's on the number line, right? When we draw a number line, don't we put a 0 on there? Yeah, so 0 is something, right? It does exist. It's weird because you think, well, nothing exists? But 0 really isn't technically nothing. Julia?
So horizontal would be no slope.
No.
And then
No.
0 slope?
Yeah, it's right here.
And then vertical.
Horizontal line, the slope is 0.
And then
A vertical line has what? I just underlined it. Has what? No slope. It's got no slope. Okay, or you could say, I heard somebody earlier say it's undefined. That's good too. That's a good way to describe it. Yeah. Represents what? You could think of it that way, but 0 is something. So I don't want to say 0 represents nothing. 0 represents no objects. All right. It's weird. It does have value, right? It does have value. You're right, but it's got the value is 0. It's kind of weird, but let's get rid of it. Okay. I told you guys a story last year. I'm not going to get into it as much, but let's say you're going skiing. Do you guys remember my rappelling story? Was when I was in the ROTC. See, you guys, for one semester in college, I was in the ROTC because this girl joined, right? And I saw her in the library. She had like a uniform on. I'm like, oh, are you in the military? She said, no, I'm in the ROTC. I'm like, ooh, I want to go to the ROTC. Meet that girl, right? Well, I'd already met her. Anyway, it didn't really turn into anything. But anyway, thank goodness, because my wife and I, well, we weren't married then. She was my girlfriend then. We were kind of like, okay, you're going to college, so I can see people, you can see people, but we're still going to see if we're really meant for each other, one of those kind of deals. Usually that doesn't work. Usually you do meet somebody else. But she dated a couple guys, one of my friends actually. and then I don't know if I consider it really dating, but I talked to, Is that what you guys say that today, don't you? But we never said that back then. We actually meant talk to, like I just physically talked to them. Doesn't mean we're going out or anything. Anyway, but we ended up back together again. So, and we've been married for 37 years. Yeah, 37 years we've been married. And we were together 7 years before that. So really 44 years we've been together. Can you imagine that? And I wouldn't want it any other way. Well, anyway, what was I talking about? Let's go skiing, okay? So if you go skiing, let's think about this. If you were on a slope like this, a horizontal slope, nobody pushed you, the wind's not blowing or anything like that, you didn't push with your poles, you're just standing there. How fast would you be going if you're standing on a horizontal surface? You would go 0, right? So that's how I like to think of it, 0 miles per hour, okay? So again, 0 is something, isn't it? So you're going 0 miles per hour. That's how I think of horizontal. Now, would you ever, who's been snow skiing before? Anybody been skiing in the snow, right? You go on these slopes, they got like green, right? They got blue, and then what's the big granddaddy of them all? The black diamonds, okay? You go to the black diamonds, and that's the toughest one. Is there enough diamonds to have a ski slope that goes vertical, perfectly straight up and down? You would die, yeah, depending on how high it is, okay? Yeah, you wouldn't have that. It doesn't exist, does it? You go to the biggest ski slope in the world, I don't know what that is, but the hardest thing, I saw the other day a guy skied down Mount Everest. First time ever. Yeah, he walked up, a lot of people walk up Mount Everest nowadays, but he walked up without any oxygen. Most people have oxygen because the air is so thin up there. He walked all the way up, right, with a bunch of people, no oxygen. He had skis. He got on his skis, and he skied down.
No way.
Yeah, it was crazy. They said it was the first time it's ever happened, and they had video of it, so I don't know. If you believe it, who knows? With AI, you never know. But I believe it, I guess. But anyway, that's kind of cool. But even Mount Everest is not completely vertical and straight down. It does have a slope to it, all right? It's got a negative slope, right, because you're going down. But anyway, Julia.
No, I was trying to say the last person that tried disappeared.
Oh, is that right? Yeah. A lot of people die, actually.
Ski?
I have skied. I wouldn't say that I ski. I haven't skied in a bunch of years.
I could
But I was a pretty good skier. Let me tell you a quick ski story. This girl's in my math class, and she actually went out with my son. They went together for a long time. Anyway,
Wait, if you did in your class, how did you go over it yourself? Did you your age? What?
no, she went with my son, so she's
Oh,
young.
like when your class said when you were teaching?
Yeah, when I was a high school teacher, my son was in high school, and she dated my son.
Your daughter was not paying me after class.
So anyway, it doesn't matter. So this girl, she was a good skier. She skied all the time, right? She always talked about it all the time. Oh yeah, we're going up this weekend to Mount whatever, and we're gonna go skiing. So she always talked about skiing. So the senior trip, when she was a senior, we went to Canada to this one place. It was up above Montreal. It was in Quebec, Mount something or rather. I forget what it was. It doesn't matter. So she was like all talking smack. She's, oh, Mr. Hamrick, I'll tear you up. We're gonna race when we get to the top, and da 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 da. I was like, all right, that'd be good. You ski all the time. I ski like once every 5 years, maybe. That's about how often I ski, and but I knew I could go down a hill pretty quick, right? So I didn't say anything. I was like, okay. We get up there, and we're like, okay, ready, go. So she's ahead at first. And then she's like swooshing back and forth like you do, It was really steep, And I was like, there's no way I'm letting this girl beat me. and so I just started going straight down, man. I tucked, man, and I just flew by her, and I waved to her as I went down. And I got down to the bottom. I was waiting. I was like, what took you so long, And so that was pretty fun. But she was but I wasn't bragging. I wasn't talking smack. She was talking to me before we did it, right? So I just had to show her that, I could beat her. But anyway, all that said, you would never see a vertical slope, would you, when you go skiing? You'd never see anything like that. So that's no slope, or it's undefined, right? So if you went down a slope like that, all the way down to the bottom of a mountain, you would probably be undefined. They probably wouldn't be able to tell who you were, all right, if you went down something like that. So that's kind of how I remember it. I have another story about rappelling. I'm not going to tell it today. All right, watch last year's video. All right, enough of that. Let's do an example and we finished. They really didn't They really did not, they kind of just jump into this. But that's okay because you've done it a couple years already. That's probably why they just jump right into this. It's called the slope-intercept form. Now we remember how to graph a line using the x and y intercepts. Remember we did that yesterday? It was the first thing we did yesterday. All right, so this is another way to graph a line. And this is probably, my guess would be, it's probably the most popular way to graph a line using the slope-intercept form. Let's write it out. And I think you guys mentioned it right at the end of class yesterday. Remember this? Y equals mx plus b. There's two things in here that are really important. One is the m. We've been talking about that. What's the m represent? That's the slope. Okay? And take a look at the name of this form. It's got slope in it, doesn't it? All right. What else does it have in the name? Intercept. What intercept? This one. And it's a b. Why in the world would they make it a b? Well, it's actually from the ordered pair. It's not really an ordered pair technically, but it's from AB. A meaning the x-intercept, which we don't really talk about that often, and B being the what? The y-intercept. The y-intercept. Okay? So the B represents the y-intercept, where it crosses the x-axis, or where it crosses the y-axis. All right? So let me just talk about that a second. Let's put a, we'll keep this blue, keep the color scheme going. So what if you had something like this? You had a line, looks like that, okay? So now you know how to find the slope, correct? So if I had a point here, and if I had a point here, I could do the rise over the run. I could do the change in y over change in x, right? y1 minus y2 over x1 minus x2. So I could find the slope. What's the b? The b is this point right here. Everybody see that? That's where it crosses the what? The y-axis. Now it also has an x-intercept. We talked about that yesterday, right? We talked about how to find the x and y-intercepts. How do you find the x-intercept? You set y equal to 0. How do you find the y-intercept? You set x equal to 0, all right? So they all combine together, and this is a nice form. It's pretty simple to use. So let's do an example with this. We are going to graph an equation. All right, let's put this here, put it over here, and let's do some work over here. Here's what we're going to do. This is example 6. It's the last example that we're going to do. Is it quarter after? Is that when we're out of here?
We get done at 25.
Oh, is it 25? Oh, good. All right. So I can take my time. I don't have to rush. All right, here's what we're going to do. We are going to graph that thing right there. And we're not going to use that x and y intercept thing. Now we could if we wanted to, right? If they didn't tell you one way or the other, but they want you specifically on this to do the slope intercept form, okay? So what we're going to do is we want to make it look like this. Does it look like that right now? Again, the m is going to be a number, the b is going to be a number, all right? Does that look like this? No, because this has y by itself. So what are we going to have to do? We're going to have to take this, solve for y, and then make it look like this. Once we do that, we should be able to graph it pretty easy. All right, so we got to do a little bit of algebra. It's not much, about 2 steps. All right, so we got to get the y by itself. So what do we have to get rid of? We want the y to stay right there. What do I have to get rid of in order to keep the y right there? The x, right? But it's a 3x, isn't it? So I'm going to subtract a 3x. I'm going to subtract a 3x. So that cancels. Bring down the 2y. Now, stop right now. Don't put 8 minus 3x. Why not? Look where the x is. The x comes before the regular number, okay? Everybody see that? So let's slide that negative 3x right here. Isn't that the same exact thing? Yeah. It just looks like that formula, though. All right, so I want the x to go first. All right, it's the same thing, isn't it? 8 minus 3x, negative 3x plus 8, same exact thing. One more step, and we're ready to graph. What would that be? Yeah, divide by 2, divide by 2, divide by 2, and now, look what we got. Now we have it in slope-intercept form. Y equals, just make this negative 3 over 2x. Notice what I did. If I make this a fraction, just put the x next to it and put the fraction out in front of it. Don't make it negative 3x over 2. Everybody see that? Make it look like this. Plus 8 over 2, which is 4. So this is what we're going to graph. So we want to take that and we want to put it onto our graph. Okay? So the first thing we're going to do is do the y-intercept. That's super easy. So where is it? 1, 2, 3, 4. Okay? So I'm going to take that y-intercept and put a point right there. Put a dot right there on the y-axis. Remember, that's the y-axis. I'm going to put a dot at the 4. What is this thing right here? That's my slope, isn't it? So what am I going to do? It's rise, it's rise over run. What is the rise? Negative 3. What's the run? Positive 2. Now you could do it this way. You might have said 3 over negative 2. Is that the same thing?
No.
It's not?
Yes.
Well, this time the rise would be what? Positive 3, and the run would be what?
Wouldn't it make it the other way?
Negative 2. Nope. It's going to make it the same exact. It's going to, both of these points will still lie on the line. Let me show you why. So let's put a 1, 2 here, put a 1, 2 right there. So check this out. Let's say I did it this way. So I don't start at the origin, start at the y-intercept. Everybody hear that? A lot of people get confused on that and they start at the origin. Put the y-intercept first, start there, put your pencil there, and what are we going to do? We're going to rise negative 3, which means we go what? Down 3. 1, 2, 3. Everybody good? And then we run what? Positive 2. 1, 2. Put a point, and then we connect them. Don't just connect from point to point. Oops.
So what's the plus 4?
That's where it started. That's y-intercept. And there's your graph right there. It's as easy as that. Do you agree? Yeah. Let's do it this way. Now I got to put some more points in here. I kind of ran out of graph. Let's see, 1, 2, 3. Is that all right? So watch this. I could go from here, and I could rise positive 3 and run negative 2. So I could go 1, 2, 3, and then what? 1, 2. Check it out. Where does it? It lands right on that line, doesn't it? So did it matter on that negative slope that I went positive first or negative first? Didn't make any difference. Okay? It still lies on that line. All right? And there you go. That's it. Do you remember this from last year? Yeah, we did a lot of this stuff last year. Now, this is still review, obviously, because I said we did it last year. It's going to get a lot more complicated. It's not just going to be straight lines like this. Okay, we're eventually going to graph some pretty crazy looking things. All right, but we got to start somewhere, right? And this is where we're starting. So this is the easiest type of graphing that you're going to be doing. So get used to it. Make sure you know how to do it. All right, enough of that. Let's write down the assignment. Again, some of you started it, some of you finished it, some of you didn't start it. Well, you got to do them all tonight then. All right, so it's section 2.2, and we are doing 1 to 37, but we're only doing the odds. Okay? Julie, did it take you that long to do that? Nah. Even though it looks like a lot of problems, it's really not. Everybody good?